In this video, we're going to explore C function prototypes. Function prototypes are declarations of functions that tell the compiler about the function's name, return type, parameter types, and the number of parameters it expects. The subtitle here says declaring function signatures before use. Let's dive in to understand what this means and why they are essential in C programming. In the content part on the left, we have a description that says function prototypes tell the compiler about function name, return type, parameter types, and parameter count. On the right, there is a code example. Let us understand the code. The first line that begins with a ***** is a comment which says, function prototype. Then we have int add into int b semicolon. Here int is the return type, add is the function name, and inside the parenthesis, we have the parameters as int a and int b. So the add function takes two integer parameters. Then there is the main function where the result is calculated by calling the add function and passing values 5 and 3 as arguments. After that, there is the function definition which actually implements the function add, which returns the sum of the two input parameters, a and b. Let's discuss why function prototypes are important. So the heading here is, why use function prototypes? Let's see some of the benefits. The benefits of function prototypes are that it allows functions to be called before their definition, enables the compiler to check function calls for correctness, improves code organization and readability, and is essential for larger programs with multiple files. Without prototypes, there could be potential errors. Look at the code snippet here. There is no prototype for the calculate function. The function is defined after it is used. Here the compiler assumes that the calculate function will take two integer parameters and return an integer. But the actual function calculates the product of two floating point numbers. So there is a type mismatch error. To avoid this, function prototypes are extremely useful. Now let's take a look at the syntax for writing function prototypes in C. The heading here is function prototype syntax. On the left side we have a code example and on the right side we have some explanation regarding the key points. The basic prototype syntax is return type function name, parenthesis parameter type parameter 1, parameter type parameter 2 parenthesis semicolon. For example, void print message parenthesis char pointer message. Another example is int calculate sum int numbers square bracket close square bracket comma int size parenthesis close semicolon. A final example is float get average parenthesis float a comma float b parenthesis close semicolon. Some of the key points to note are that parameter names are optional in prototypes. Prototypes must end with a semicolon. They are usually placed at the top of the file or in header files. The function prototype must match the function definition exactly in return type, parameter types, and parameter order. Now let's explore how function prototypes are used within header files in C projects. The heading here is function prototypes in header files. On the left side, we have an example of a header file named math_utils.h. This header file contains function prototypes for various mathematical operations such as add, subtract, multiply, and divide. Note the use of header guards using #ifindef, #define, and #indif preprocessor directives. These prevent multiple inclusions of the same header file, which can lead to errors. On the right, we have a main.c program. Here we include the standard input-output.h and math_utils.h header files. Then we use the add function whose prototype is declared inside the math_utils.h file. Header guards prevent multiple inclusion of the same header file. Include the header file to access function prototypes. Let's wrap up with some best practices for using function prototypes and a summary of what we have covered. The heading here is Best Practices in Summary. Some of the best practices include always use function prototypes, place prototypes in header files, use header guards to prevent multiple inclusion, and keep related functions in the same header. Some of the common mistakes to avoid are mismatched return types, incorrect parameter types or order, missing prototypes for library functions, and forgetting to include necessary headers. To summarize, function prototypes are essential for reliable C programs. They enable the compiler to check function calls for correctness, improve code organization, and allow functions to be called before their definition. Always declare prototypes for all functions and organize them in header files for larger projects. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.